Assalamu alaikum everyone. Today we are going to start the new exercise which is exercise 4.4. Let's start with question number 1. Question number 1 says that we need to give quick answer to these questions without doing any procedure. So they are saying that if the HCF of two polynomials, I'll write the first polynomial here, which is x cube plus 5x square plus 6x. This is the first polynomial. And the second polynomial is x power 3 plus 9x square plus 14x. Now, what are they saying? They are saying that we have these two polynomials and their HCF, their highest common factor, is obtained as x square plus 2x. Now, with this given data, they are asking us some questions. Let's see what the first part has to offer. The first part says that what would be the HCF of 5 bracket first polynomial and the second. So look, we have the first polynomial and this is the second polynomial. If the first polynomial is 5 bracket this polynomial, this means that throughout this polynomial 5 is being multiplied and the second polynomial remains the same. Then what will be the HCF? So the answer to this question will be the same, that the HCF will remain x square plus 2x. Now why? Look, this is the first polynomial and this is the second. There aren't any common factors between these both. For example, I have 5 and here I have 1. Let's assume I have 1. So there is nothing common between 5 and 1. The greatest common divisor, or GCD as you like to call it, there isn't any common thing between them. So therefore x square plus 2x will be the answer. In part B, they are saying that instead of the first polynomial being multiplied with 5, we have the second polynomial which is being multiplied by 2. So whether the first polynomial is being multiplied by any number and the second is not, or if the second is and the first is not, then they don't have a greatest common divisor. So the HCF will remain just the same. So x square plus 2x will be the answer for part B2. And now I'm not giving the answer in much detail because they are saying that we need to give quick answer to these questions without doing any procedure. Okay, so the third part says that what would be the HCF. So they are saying what would be the HCF if the first polynomial was multiplied by 3 and the second polynomial was multiplied by 7. So look, now the first polynomial is being multiplied by some sort of number and the second is also being multiplied by some sort of number. But they still don't have anything in common. So the answer for this part will remain the same, x square plus 2x. Now in part number 4, they are saying what would be the HCF if we have 15 being multiplied in the first polynomial and then in the second polynomial we have 25. So look, now the HCF will be changed. How? In the first case we have 15 and in the second we have 25. You will notice that both of these are divisible by 5. 15 is divisible by 5 and it produces 3. 25 is divisible by 5 and it produces 5. So we can say that the greatest common divisor between these two is 5, right? So the answer will be for part D, 5 bracket x square plus 2x. So these are the parts for question number 1. Now the last part, which is part number E, what does it say? It says that does the HCF of the given polynomials will remain unchanged if both are multiplied by x. So it's basically saying that on the first polynomial, let's suppose instead of any number, the polynomial is being multiplied with x, and same as for the second polynomial, the polynomial is being multiplied by x. So will the HCF still remain x square plus 2x? The answer is no. Why? Because the greatest common divisor between these two is the same. X and x can cancel each other out. So our answer for the last part will be no, and the resultant will be x bracket x square plus 2x. So this is question number 1. Question number 2 states that we need to find the LCM of the following monomials by completing the table. So let's attempt part number 1. In the first monomial, we have 8x power 6y, and in the second, we have 4x square yz. So first, how are we going to find the LCM? We're going to find the HCF, which is the highest common factor, and the uncommon factors. So in order to find the LCM, the formula is HCF, which is basically the common factors multiplied by the uncommon factors. This is our formula for LCM. So first we have 8x6y and 4x power 2y7. So how are we going to simplify both? So 8 and 4 are divisible by 4. So we can write that we have 4. And then we have x power 6 and then we have x power 2. So I'll pick x power 2. Why? Because I'm first finding the HCF. And then we have y and y here, so y will cancel each other out, so that leaves us with y, and we do not have z, so this is our HCF. Now if we use this HCF and divide this by the first monomial and the second monomial, then we will obtain the uncommon factors. Okay, so how are we going to do that? 8 divided by 4 results in 2. So I'll just write down here 2. Then x squared divided by x power 6, that results to x power 4. And then we have y, so y and cancel each other out. So this is the first uncommon factor. Now we need to find the second uncommon factor, which is this. So if we divide our HCF with this, 4 and 4 will cancel each other out. X square and x square will cancel each other out. Y and y will cancel each other out. So the remaining we will have is z. So this is our second uncommon factor. Now if we have 2x power 4z, if we multiply both of these together, we will have 2x power 4z. So this is our uncommon factor. We need to multiply this number with 4x square y. 4x square y. So 4 2s are 8. X power 4 with x power 2 will result in x power 6, and then we have y and z. So this is our answer for question number 2, part number 1. We have 12 x power 2, y power 4 and z, and then we have a monomial which is 24x square yz. Okay, now first we're gonna find the HCF for both of these. So how are we going to do that? Now first, if you look at the numeral, we can see that 12 and 24 are both common. So we will take 12 as a common value. Why? Because 12 2s are 24. Then we have x square and x square. So we will have x square. Y power 4 and y, I'll just write y, and z, so that is just z. So first I will write this. After writing this, I just need to find the uncommon factors. So 12 and 12 will cancel each other out. X and x square will cancel each other out. Y power 4 and subtracted from y results in y3. Now let's move on. 24x power 2 yz. So 12 2s are 24. I'll just write here 2. Then we have x power 2 divided by x power 2, that results in nothing. Y will be cancelled and we will just have z. So this is the second uncommon factor and this is the first uncommon factor. Now we need to multiply all of these three values for LCM. So 2z and y cube, that results in 2y cube z multiplied by 12x square y. So what are we going to do? So 12 multiplied 2 is 24. So I'll just write 24. Then x power 2, I'll just write it as it is. And then we have y cube and y. So that results in y power 4. And then in the end, we will just write z. So this is our answer for part 2. Now let's move on to part 3. I'll just write the part here. Okay, in the third part, we have 18x power 3z Okay, and then in the second we have 9xy square z, and then we have 6x power 6yz cube. Now what we will do? We will find the HCF. So 18, 9 and 6. All of these three values, can they be divisible by some sort of number? So let's think. So we have 6, we have 9 and we have 18. If we pick 6, but 6 and 9 aren't in the same table. So what are we going to do? We're going to choose the table of 3. Why? Because 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15 and 3 6 are 18. So I'll just write 3 here. After writing 3, we have x cube, x, and we have x power 6. So I'll just pick x. Why? Because I'm choosing the lowest power, because we need to find HCF first. Then we do not have y in the first part, so we will skip that. And then we have z and z cube, so that will result in z only. So this is our HCF. Now let's find the uncommon factors. So the uncommon factor for the first, so we found out that 3 6 are 18, so we will write 6 here, then x square and z will be cancelled. Then we found out that 3 3s are 9, and we will just have 3y square. And then what do we have here? 3 2s are 6, so we will write 2 here. We will just have x power 5 here, y here, and we will have z square. So now we will multiply all of these values with each other. So let's write down the uncommon factors first. This is 6x square, then we have 3y square, and then we have 2x power 5yz square. Now 3 multiply 6. What is 3 multiply 6? 6 multiply 6 is 2 is 12, 6 3s are 18. And if we multiply 18 with 2, we get 36. So I'll write 36 here. Then we have x square and x power 5, that results in x power 7. And then we have y square and y, that results in y3, and then z square will remain as it is. So this is our uncommon factor multiplied with the HCF, which is 3xz. So if we multiply this with 3xz, firstly x power 8, then y power 3 will remain the same, z power 2 will change to z power 3, and now we will multiply 36 with 3. So 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6 are 18, 3 3s are 9, and 108. So this means that the answer is 108 x power 8 y cube z cube. So this is our answer. Okay everyone, so let's attempt question number 9. Question number 9. It states that we need to find the LCM of the following expression. The first expression is 9a square b minus b, and the second expression is 6a square plus 2a. Now first we will find their HCF. So let's find the HCF for 9a square b minus b. So first we notice that b is a common value. We will pick b as a common value and write 9a square subtracted from 1. And then we will write b bracket. 9a square can be simplified much further. It can be written as 3a whole square subtracted from 1 square. And then now we will use this in the a square minus b square formula, which is equal to b bracket 3a plus 1 and 3a minus 1. So this is the first HCF for our first expression. Now for the second expression, what will be the HCF? So we will pick the common values between these two, and the common is 2a, and then I'll write 3a plus 1 inside, because 2a was divided by the first and the second, so that produces 3a plus 1. So now we need to find the uncommon factors. But first, we simplified the first factor. This is our first factor, we simplified it, and then this is the second factor, we simplified it. We didn't find the HCF. So in order to find the HCF, here we have b bracket 3a plus 1 and 3a minus 1. Here we have 2a bracket 3a plus 1. So what is the common between these two? So 3a plus 1 and 3a plus 1 is common. So this is my LCM. Now I need to find the uncommon factors. To find the uncommon factors, this HCF which I just found will be divisible, which will be divided by these both answers. So 3a plus 1 will be removed, so we will have b bracket 3a minus 1, and it will be multiplied with 2a. So in a sense we can just write 2ab bracket 3a minus 1. So I will write 2ab 3a minus 1. So this is what I have. Now if we multiply both of these, we will get the LCM. So the LCM will be equal to 2ab bracket 3a plus 1, and you can write 3a minus 1. Now this is the answer, but what if we want to simplify this much further? We can write 2ab, and instead of 3a plus 1 and 3a minus 1, we can just write 9a square minus 1. So this will be our final answer. Now let's move on to question number 10. In question number 10, the first expression is p cube q subtracted from pq cube. Now we need to express this expression. So common between these two is p and q, and then inside we will write p square minus q square. So p square and minus q square, it is equal to a p plus q and p minus q. So pq bracket p plus q and p minus q. This is our first factor. Now the second expression, we have p power 5 q square subtracted from p square q power 5, and it is equal to p square q square. Why? Because it is the common between these two, and then we're going to write p cube subtracted from q cube. So we learned this formula in the previous exercises, which was a cube minus b cube. What is it equal to? Does any of you remember? Yes, a cube minus b cube is equal to a plus b, and then a square plus b square minus ab. So this is our formula. And now what do we need to do next? We will place the the values in this formula. So I can just write p square q square bracket p, instead of p cube and subtracted from q cube, I will simplify it and write p plus q and p square plus q square plus pq. Now this is our second. Now we need to find the common, which is the HCF between them. So what will be the common factors between them? Look at the first, we have pq bracket p plus q and p minus q, and in the second we have p plus q. So p plus q and here p plus q will be taken as common factor. So I'll just write p plus q. After writing that, we will just write the uncommon factors. So what will be the uncommon factors? So we will have pq bracket p minus q, and we will also have p square plus q square plus pq. So I can just write pq bracket p plus q, and then we're gonna have here p square q square, and then inside we're just gonna write p square plus q square plus pq. Now we need to find the LCM. So both of the common and uncommon factors will be multiplied in order to get the result. So our answer will be p cube q cube, because p square multiplied p is p cube, q square multiplied q is q cube, and then we will write p plus q as it is, and then we will just write p square plus q square plus pq. Now what do we need to do? We can just simplify this much further. So p plus q and p square plus q square plus pq is also equal to a cube minus b cube, and I think I made a mistake right here. This will be subtracted, and here we will have addition. So this is our answer for question number 10. Now let's move on to question number 11. In question number 11, the first expression is 4x square y subtracted from y. So what is the common between this expression? So we will take y bracket and then we can write 4x square minus 1. Now we have 4x square minus 1. We can simplify this much further. So we can write 2x whole square minus 1 square. And then we will use the a square minus b square formula, which is y bracket 2x plus 1 and 2x minus 1. So now the second expression is given, which is 2x square plus x. Now what is the common between these two? We can just pick x bracket 2x plus 1. So now let's find the HCF or the common factors. So 2x plus 1 and 2x plus 1, we can just write that. And then we need to find the uncommon factors. So what we will do, we will write uncommon and we will find the uncommon factors. So the first will be xy 2x minus 1. So we can write xy bracket 2x minus 1. And now we need to find LCM, which is the multiplication or the product of both HCF and uncommon values. So we can just write xy bracket 2x plus 1 and then we will write 2x minus 1. So this is our answer for question number 11. Now let's move on to question number 12. Question number 12, we have the first factor, which is x square minus x minus 6. Now look, this is basically a quadratic expression. So the coefficient of x square is 1 and here we have negative 6. 1 multiply negative 6 is negative 6. So let's find the factors. So that will be 3 and 2. We need to find the factors for this quadratic expression. So if we write x square minus 3x plus 2x subtracted from 6. Now we have 4 values, 4 terms and 2 pairs. So we will pick x bracket x minus 3 and then I'll choose plus 2 bracket x minus 3. Then I can write x minus 3 as my first term and x plus 2 as my second. So this is the answer for question number 12, but this is only the first part. Then the second part, the second expression is given, which is x square plus x minus 2. And this is equal to what? So we need to find the factors. You need to find the coefficient and multiply it such that the factors will be available. So the factors for this will be x square will remain as the same, but x plus 2x subtracted from 2. Now we have 2 pairs and then we will write x bracket x minus 1 then plus 2 bracket x minus 1 here 2, and then we can just write x minus 1 here and x plus 2 here. So this is our second factor. Now for the third factor, we have x square minus 4x plus 3. Now what will be the answer to this question? We can write x square minus x minus 3 x plus 3 because I just found the factors by multiplying the coefficient and the number, which is 3, and then I found the factors. So this I have 2 pairs. I can just write x bracket x minus 1 and minus 3 bracket x minus 1. Okay, and then I can easily just write here x minus 1 and x minus 3. So I found the 3 factors. Now what will be the HCF? The HCF will be x plus 2. How will the HCF be x plus 2? Because look, in the first we have x plus 2 and in the second we have x plus 2, but in the third we do not have it. So we're just gonna pick 2 from now. So the first and the second, their common is x plus 2, and then we need to find the uncommon. If we subtract x plus 2 from all of these, we will just get x minus 1 and x minus 3. And now we need to multiply all of these 3. So the LCM will now be equal to x minus 1, x plus 2, and we can just write here x minus 3. So this is the answer to question number 12.